This is the SAIC RTR-4 Integrated Imager. This is a portable X-ray detector usually used for suspicious package inspection. These units are available reasonably inexpensively, surplus. They connect to a computer and control a remote X-ray source. You position the X-ray source some distance from the detector, put the suspicious package or box up against the detector and X-ray it, and then the image is transferred to the computer via Ethernet. The imagers run off of either a remote power source between 12 and 24 volts or a nickel metal hydride battery. This is a DR35 or DR35S, a 10.8 volt nickel metal hydride battery. The detector units themselves can charge the battery if connected to an external power source. These external units connect to the computer via an Ethernet port over a LEMO connector, and that's the green connector for the Ethernet. The second yellow connector, also LEMO connector, connects to the remote X-ray tube. This is just a relay contact port, normally open, normally closed contacts. When connected to the Ethernet, there's an adapter lead which you can build, plugs into the green port, and converts that to an Ethernet cable that can plug into your computer via an Ethernet extension port. These imagers originally came with a laptop controller, SAIC RTR-4 notebook controller. These are getting fairly old. They're old HP laptops, Core 2 Duos, typically running Windows XP. The software on laptops can be moved to Windows 10 and will run fine on Windows 10. The laptops are set up with an Ethernet address of 10.25.120.100, subnet mask 255.255.248.0. Not sure if the subnet mask is required. Seems to work fine without that on Windows XP. The computer will need to have a dedicated Ethernet port set up to run the imager, as it needs to be on the 10.25.120.100. So you'll need a dedicated port for that. When connecting to the imager is on a fixed IP address of 10.25.120.108 and it connects on port 7000. The remote control cable is another LEMO connector that connects to a portable X-ray source. Those are typically the Golden Engineering X-ray sources, and then this just triggers that via the immediate fire line to the source. So these imagers, typically when you buy them surplus, they come with an extension spool of the cable. The spool is just a LEMO extension cable. You don't necessarily need that due to the cost of LEMO connectors. It's fine just to plug an Ethernet extension cable with a gender changer in place of this long spool, and that'll make it slightly cheaper when building your own cable. So the ports on this are LEMO connectors, as mentioned. The green connector is a LEMO FGG.1B.308. These views for these pins are the socket side or the solder cup side on the plug. There's a jumper between two pins, and the rest go to two of the TX-RX pairs on the Ethernet connector. So pin 1, pin 2, pin 3, and pin 6 on the Ethernet connector. The plug side for triggering the remote X-ray source is a LEMO FGG.1B.306. Again, this is looking at the socket or the solder cups on the plug. Relay normally open, common, and relay normally closed. So let's have a look at what's inside these imagers. So inside we have, let's open, dismantled some of this for you. So here is the battery holder, and then there's a power supply board on the inside as well. These cables go over to the imaging system. This is basically just a frame grabber board connected to a high sensitivity camera, which looks off of a mirror assembly. So here's that mirror. It looks off the mirror at a X-ray fluorescent screen. This is probably a zinc sulfide screen. It glows green when hit by X-rays. It's fairly emissive. There's a little orientation indicator in the corner. It's a ball bearing in a little cup which tells you which way is down in your. Sometimes when you buy these imagers surplus, the camera is unfocused, leading to very blurry images. There's a set screw here, and then an adjustable ring, and you can focus the camera lens. There's two separate adjustments. One's probably focus, the other is probably zoom. And then there's calibration files in the control software that allows you to actually measure the dimensions of things on the front that are laying up against the front panel of the imager. So to focus the imager, it may help to have a X-ray, a phantom, or resolution test article. The ones that come with this imager is basically just a series of wires between there's 22 gauge, 20 gauge, 22, 24, 26, and 28 gauge wire. The imager it'll see the 28 gauge wire, so it'll go down to fairly high resolution. So the way this works is when the software commands it to fire, it turns on the camera integrator. Then there's a relay here which controls a second relay in the power supply unit, and that relay closes and connects to the X-ray imager to fire the X-ray pulse, which is then seen by the camera from the fluorescent screen off the mirror by the camera, and is then transferred to the computer. So that's how this system works. They're fairly cheap compared to X-ray flat panel detectors, though not nearly as high resolution. That they are very portable, very rugged units that are available surplus fairly cheap.